Hello, my name is David Poppleton, Sales Manager at Fast Fill Systems. Today I'm going to introduce you to a variety of products that we have in regards to pressurized fueling, and then later I'm going to discuss with you how pressureless fueling will work and the advantages that we have. In a pressurized fueling system, there are three components that are necessary for this to work. The three components that I'm going to talk about right now would be the nozzle. In this case, the nozzle is our Atlas nozzle. We have several different types of nozzles that are in the market, but this is our newest nozzle. This fuels between 30 and 150 gallons per minute. We have other nozzles that will fuel up to 211 and 256 gallons per minute, depending on what your pump can put out and what your desired results will be in fueling the tank. The other component that we have would be our fuel receiver. In the market, traditionally, or what you'll see on many machines out there from the OEMs, will be an aluminum receiver. The aluminum receiver is acceptable, it's okay, but I don't think it's the best. The aluminum receiver has the tendency to wear out faster due to the environment that is out there. If you've seen fuel receivers in these fuel tanks, they're covered in dirt. They may not be wiped down when the fuel nozzle's attached, and they tend to dig into that metal. And when it digs into that metal and they're not taken care of, receivers can tear out the seals that are on the inside of this fuel nozzle. When you tear out those front seals, or wiper seals that we call them, they'll result in having fuel come out of the front end of the tank, and you'll have contamination on the ground. It's not a desired result. For us, our bread and butter would be using a nickel-plated steel receiver. The steel receiver comes in a variety of different types of spring strengths. The spring strength has a specific color on the poppet, which is this piece right here, ranging from 7 psi to 13 psi. The other type of receiver that we have would be a check valve. This is our check valve. It's labeled as an R150CV. The check valve has two components. You have a base, which is this red part, and this red part has a 2-inch NPT thread that goes directly into the tank, and it has a poppet on the inside of the tank, so when the nozzle is attached to this receiver and the fuel is being put into the tank, this poppet opens up. When it's not being fueled, it closes off. There's advantages to this check valve, and I love this. One is that it has a check valve on it, so when it's time to change out a receiver, all you have to do is just remove the receiver from the check valve. You may have a few ounces of fluid on the inside, but you don't have to drain the tank. So as you can imagine, instead of spending a lot of time and having to drain the tank and putting it somewhere and then having to fill it back up again, the check valve is in place inside the tank. You save a lot of time and money in having to just change this out. It only takes couple of minutes to do this, and you're done. The one thing to know specifically is that this isn't the same type of receiver as our standard receiver. This has different type of thread. It's a proprietary thread that we have here at Fast Fill Systems. It's the only type of receiver that will fit inside this check valve. So this is our R150CV. The R150CV works up to 150 gallons per minute. This one is an R800CV. This has just recently come out on the market. This will work up to 800 liters per minute or 211 gallons per minute. So it handles a higher volume inside the fuel tank. The other reason that I think this check valve would be better than having a standard receiver, in my opinion, not only is it save downtime on having to replace the receiver and not have to drain the tank, but the other thing is there are times when that pressure is built up on the inside of the tank. When that pressure is built up and you remove the nozzle, sometimes this poppet could be open just a little bit, and that pressure will force fluid to spray out. You get that back spray, and there's a safety issue, because who wants to have diesel sprayed in your face? The other thing is it's an anti-theft piece. The reason why I say that is because the check valve is closed off inside the tank. Typically what somebody would do, and if they wanted to distill diesel from the tank, is open up the poppet and then hold a bucket underneath it and fill their bucket up and walk away with it. Because that check valve's closed off, you only get to get a couple ounces of fluid inside. That's inside this piece between the receiver and the check valve. You won't be able to get anything else. So you're saving money. You're not allowing other people to steal your money or steal your diesel from your tanks. So those are some great benefits of having a check valve. The third piece that is involved in having a pressurized system would be a vent. This is one example of a vent. This is our V150. We have others that have a coupler on there, that if you have a coupler where you need to weld a vent onto the tank, or one with a whistle. There's a lot of different varieties, but how this vent works, which is basically how a pressurized system will work, is when the nozzle is attached to the receiver and you turn on your nozzle and you're filling up your tank, air is escaping outside the vent, this is a 2-inch NPT So this is going to be on top of the tank. Air is going to escape out of this port while you're fueling the tank. And as the fuel level rises up, these little plastic balls are going to rise up and seat up against the base of the stem. Now, the stem is right here standard at 5 inches, but you can have one at 7 inches, you can have one at 12 inches. There's a lot of varieties. There's also one with a safety valve, or not a safety valve, but a safety stem that goes over this piece, where if you have a specific machine where there's foam building up and you have a result of where you can have the tendency of fuel or foam spitting out of the vent, that safety tube, it looks like Swiss cheese, prevents that foam from having to be forced out. It also prevents the foam from lifting these balls up and closing off the fueling process prematurely. So as you're filling up this fuel tank and the balls are rising up, this seats up against the stem and it won't rise up anymore, and then the air stops to flow, pass out of this vent. Then what happens is that the air inside the tank pressurizes between 7 to 10 psi, or 13 or 12, however you want to have it resulted. It pressurizes, it triggers the spring inside the receiver to close off on this poppet and shuts the nozzle off. The pressurized system it's a good system and it's reliable. It's definitely a lot better compared to having to top fill your tanks. You know, there's times where people are top filling their tank and they're having to climb up on a ladder or having to climb up on top of a tank and fuel it. And there's safety hazards involved in that. 70% of deaths are resulted in heights of 3 feet or higher. You want to eliminate as many safety hazards as possible. So if you're top filling a tank, then you want to make sure that you can retrofit a tank, whether it's cutting and welding, or you already have the 2-inch ports on the bottom and on the top for your receiver and your vent. That way you're eliminating a lot of safety hazards involved in that. Coming up next, we're going to talk about pressureless and how that's a lot better than what we have in front of us. When the nozzle is attached to the receiver, fuel enters into the tank through the shutoff valve. There's also fluid entering the signal line or the hose that leaks out on top of the level control. The pressureless system works when the fluid rises up to where the float is on the level control. The float rises up, it seals off the fluid where it's coming out of the signal line, creating pressure inside the signal line and returning back into the shutoff valve and turning the nozzle off. At the same time that the fuel is entering the tank, there is air that's coming out of the filter vent, which is the FFV 150. The FFV 150 has 2 check valves. When air is escaping out of the tank during the fueling process, this check valve opens up, allowing air to escape. On this end of the check valve, this part closes off to prevent any air, moisture, contaminants inside of the tank to clog up the filter that you'll see in the image. When air is being drawn out of the tank, the check valve on this end closes off to prevent any air or moisture or the contaminants of the environment to enter into the tank. Whereas on the other end of this check valve, this part opens up by entering non-contaminated air into the tank and having a more effective machine and fuel injectors.